Hi, my name is Florian Edukashi. In this video, I'm going to explain how one can use a linked list internally to implement two very common data structures, the stack and the queue. I will also do a walkthrough the time complexity of their main operations. Now, as we know, a linked list is simply a collection of nodes, where each node contains a value and a pointer to the next node. This makes it very efficient to insert or remove elements at the end, though it doesn't support random access like we know arrays do. Okay, now taking the stack using the linked list. As we know, a stack works on the principle of last in, first out. That is the LIFO. Now, to implement a stack with a linked list, the simplest approach is to treat the head of the linked list as the top of the stack. Okay. Now, when using push, we push an item, then we insert it at the head of the list. This is constant time O1. Now, when using pop, or when we pop, we remove the item at the head, which is again O1. Now, using the getUp function of the peak, we just look at the value stored at the head without removing it. Okay, that's also O1. Now, when it is empty, okay, we check whether the head is empty. Now, by always working with the head of the list, all stack operations become constant, which makes this a very efficient element. Okay, now let's move to the queue using a linked list. Now, as we know, a queue works on the principle of first in, first out, or FIFO, which is opposite to the stack. To make this efficient with a linked list, we keep two pointers, one pointing to the head, which is the front of the queue, and one pointing to the tail, which is the back of the queue. So to enqueue, we add an item, we attach it to the end of the list at the tail. Now this is O1. Now to dequeue, that is when we remove an item, we take it from the head of the list, which is also O1. Now in terms of size, if we keep a counter that updates whenever we enqueue or dequeue, we can return the size in O1. Without a counter, we would have to traverse the list, right, which would take ON. Now, in terms of it being empty, we check whether the head is null or whether the size counter is 0, which is O1. Now, it's important to remember that when the queue becomes empty, both the head and the tail pointers should be reset to nil, so we don't leave any remaining pointers. So here are the takeaways, okay, from this demonstration. One, a stack can be built efficiently by using the head of a linked list at the top, making all its operation O1. For a queue requires both a head and a tail pointer to achieve O1 for both enqueue and dequeue. And with a size counter, one also gets O1 for size. Both structures use O and space for n elements. So this is my explanation to the exercise, the interview questions. I hope this explanation helped you see how powerful linked lists can be in building other data structures. Thanks for watching.